Okay. What I'm going to teach you is what is called is from the uniform. So if I give you a rule that looks like this, okay, this is a meter rule, and then it's called a uniform meter rule. I'm repeating, uniform meter rule. Uniform. This only applies for a uniform meter rule. Okay, uniform meter rule. This part uniform, you have to know uniform. If it's not a uniform, it doesn't apply. So if, for example, I put a pivot here, okay, and then from here to here, I say, for example, from here to here it's 20. From there to here, I can say, let's say, meaning here it's 0, isn't it? So 0, 20. Let's say here I put 50. Here I put, I don't know, let me not put 50 there. Let me put 40. Let me say I put 40 here. I put 40 here. And then I put 100 here. At the end here, I put 100. I put 100. At the end here, I put 100. So it's 100 there at the end. Okay? 100. Okay, this part is 100. On top there, it's 100. Okay. And then they ask you a question, says, find, let's say here I even put a weight, something weighing here. Let's say I put a weight here that is weighing, let's say 2 kgs. Okay, it's weighing down here. It's on top there. It's weighing down 2 kgs. And then I tell you what is the weight. Find the weight of the meter rule. Okay, we're trying to find the weight of this meter rule. The one that is in red. We're trying to find the weight of it. Because they've said uniform, the way you solve it, you have to be careful. So the first thing you do is this. This is a uniform meter rule. Okay, a uniform meter rule. So we said here it's 100. Here it was 20. Here it was 40. And then the weight is here. We said the weight here is what? The weight here is 2 kgs. Okay. And then there's a pivot here at 40. That's where the pivot is. Okay. And then here it is 0. The first thing you do is you find the moment. Okay. Moment is force times distance. So it's always like a seesaw. So from here to here, it is what? So meaning this is the one that you're going to use, this. Okay? This is what you're going to use. So you say, moment on the left must be equal to moment on the right hand. Okay? So, moment on the left, what's the formula for moment? It's force times the distance. Again, this side is force times the distance. Assuming that all these are in centimeters, I didn't write. All these are in centimeters, all of them are in centimeters. Okay? Everything is in centimeters. So if all of them are in centimeters, there is no need of converting to meters. I repeat, if all of them are in centimeters, work with centimeters. If all of them are in centimeters. Okay, so what is the force? So you look at the force this side. Always know that the force always acts, since this one is a uniform meter rule, the force will always act halfway of the full distance. The force on the uniform meter rule, it acts halfway. So it means if here it's 0, okay, there it's 100. The force will always act for it. The force which I'm looking for act halfway. It will always act at 50. Why? Because the full meter rule is how much? Is 100. So half of 100 is 50. So the force will always act at half the distance of the meter rule. If the meter rule is 400, the force will act at 200. Okay, if the meter rule is 1000, the force will act at halfway. The force of the meter rule will act halfway, which is 500. So it's just half of the total distance of the rule. If the rule is 100, it's 50. If the rule is 1000, it's acting at 500. If the rule is 500, it's just acting halfway, 250. Okay, so the force is, have you seen this is 20, this is 2 kgs. So for you to convert that mass to weight, you have to multiply 2 kgs by 10. Okay, because it's in kgs, so times 10, because gravity is 10, so you convert it to weight. So it means 2 kg times 10, that is 20 newtons. Okay, so it means on force there I'll put 20 times, what's a distance? What's a distance from here? What's a distance from there to where 2 kg is acting? Here to here, there it's 40, there it's 20. So it means 40 minus 20 is 20. So it's 20 here again. Have you understood? This 2 kg is acting at 20 meters from the pivot, because here it's 20, there it's 40. So it means for me to move from here to here, it's 40, because it's 40 minus 20 equals, this is x. This is the weight of the rule which I'm looking for, x. I do not know, but it's acting at 50. So what is the weight? X. I do not know. Times, what is the distance it's acting? It's acting at what distance? From the center here to here. So meaning that it is 50 minus 40. So it's acting at 10. This distance from here to here, it is 10. Here it's 40. So for you to move from 40 to 50, it's 10. So this distance from here to here, it's 10. Okay. So 20 times 20 is equal to x times 10. Okay. That is 400 is equal to 10x. So divide by 10, divide by 10. Therefore, x is going to be equal to, this one comes out 40. So 40 what? It's a weight. So it's 40 newtons.